Another example for the electrolysis of electrolyte, electrolyte in aqueous solution is the electrolysis of aqueous potassium iodide. So it's a mixture of two electrolytes. So again, this time it's water and potassium iodide. And the possible reactions of the electrodes are, so as a cathode, is either hydrogen gas or the potassium metal. And at the anode, it's the oxygen gas or the iodine gas. So mag-compete sila. The next thing we do is to find their reduction potentials from the standard reduction table. So for water, for the reduction of water to form hydrogen gas, it needs 0.828 volts for it to happen. And for potassium, it's 2.936 volts. And then for the oxidation reactions, so remember ha, nga oxidation siya. So, gikan sa standard reduction nga table, balihon siya. So, just remember also to baliktad the sign. So, for water, to produce oxygen gas, it needs 1.229 volts. And for iodine, it needs 0.534 volts. So, in the cathode, mas gamay ang need ni water. So, water will undergo reduction to produce hydrogen gas. And in here, in the anode, mas gamay ang need ni iodine. So, iodine will undergo oxidation. Alright? So, the overall reaction, therefore, is so si water ug si iodine. So, this is the overall reaction. You just add the two equations and the cell voltage needed, standard, is 1.362 volts. So, in this cell, water is reduced to form hydrogen gas and the iodide ion is oxidized to form iodine gas. So, potassium and the hydroxide ion will stay in the solution. So, there is this bubble. There is a space here indicating that a gas was formed. This is the hydrogen gas. And this is the other tube is brownish in color. So we can see here that iodine is produced at the anode. So kani siya. This is the gas. So that's not, there's no kuan there. That's the gas. And then the pink color of the solution is indicative of the presence of the OH ion. So butang siyang phenolphthalein, diba? If you put phenolphthalein, it's basic. So we can see here that it's a basic solution indicating NiOH. Alright. Next example is this time. So, sa katong sa molten, ang gi-example kay molten sodium chloride. So, unsay difference kung ang gamiton na kay aqueous sodium chloride? So, diba sa molten ka sodium chloride, gidugangan lang siya calcium chloride in the actual production para mo decrease ang iyang melting temperature. But it's still melted. Here, sodium chloride is really dissolved in water. So there are two possible reactions happening at the cathode. It's either the formation of the hydrogen gas or the sodium metal. And at the anode, it's either mo form of oxygen gas or chlorine gas. So from the reduction table, so for water, again, it needs 0.828 volts. And for sodium, it needs 2.71 volts. So it's very obvious, mas gamay kaayo ang ginid ni water. So water will undergo reduction to produce the hydrogen gas. And then at the anode, it's either the formation of oxygen gas or the chlorine gas. And there is only a small difference between the two. So for water to undergo oxidation, it needs 1.229 volts. And for oxidation, it needs 1.36 volts. So looking at these values, we can see nga makaingon ta nga, okay, si water ang mo undergo oxidation kay need siya og lesser nga voltage. So this is actually a special case because ideally, dapat si water ang ma-undergo oxidation, but in the actual electrolysis, in the production, it's not oxygen that will be produced, but it's actually chlorine gas. So in the actual electrolysis of aqueous sodium chloride, chlorine gas is formed at the anode instead of oxygen. This is because the formation of oxygen involves higher activation energy, thus kinetically less favorable. So, bale, mas need siya, or in the production, mas paspas ang formation sa chlorine gas. Yan nilang pagkastorya. Mas ma-form ang chlorine gas kumpara ni oxygen gas. So, kuan man sad nato nga gamay ra kayo ang difference. Fast formation of the chlorine gas will overcome aning sa oxygen gas. So, in the actual nga electrolysis of aqueous sodium chloride, so there is a formation of the hydrogen and the chlorine gas. So, in this cell, water is reduced to form hydrogen gas and the chloride ion is oxidized to form chlorine gas. And then the sodium and the hydroxide ion will remain in the solution to form aqueous sodium hydroxide solution. So, this actually is a process that's very important. So, this is the chlor-alkali process because this is used to produce chlorine. No? So chlorine is very useful to purify drinking water, and large quantities are consumed in making plastics such as PVC. Diba? Chlorine is used in pools, so there are many uses of chlorine. So it's this is produced in this reaction. And then also for the hydrogen gas, which is used chiefly in the synthesis of ammonia. And aside from that, so diba ang sodium ion ug ang hydroxide ion kay mo remain in the solution. So kadong sodium hydroxide, so muna siyang gitawag og chlor-alkali process because an alkali is produced. So what is kaning siyang sodium hydroxide is an alkali, and it's very useful. It's used in the processing in the pulp and paper processing industry. It's used in the purification of aluminum ore and also in the manufacture of glasses and textiles.